Okay, lesson 6.4 is about special parallelograms. We're going to use properties of diagonals of rhombuses and rectangles and determine if a parallelogram is a rhombus or rectangle. So to do that, we have some new theorems. First about rhombuses. Theorem 6.9. Each diagonal of a rhombus bisects two angles of the rhombus. So AC bisects angle BAD and angle BCD. So angle 1 is congruent to angle 2. And like I said, AC bisects BCD as well. So angle 3 is congruent to angle 4. Remember, bisects means it cuts it exactly in half. Theorem 6.10, the diagonals of the rhombus are perpendicular. So in the picture off to this side, diagonal BD is perpendicular to AC. Then we have a theorem about rectangles. It says the diagonals of a rectangle are congruent. So in our picture, AC is congruent to BD. Then there are a few more about parallelograms. If one diagonal of the parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. If the diagonals of the parallelogram are perpendicular, then the parallelogram is a rhombus. In theorem 6.14, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we can prove it both ways. Up here, we're saying if we know it's a rhombus, then this is true. Down here, we're saying if this is true, then we know it's a rhombus. Okay, so let's look at some examples. Finding angle measures. Find the measures of the numbered angles in the rhombus. Theorem 6.9 states that each diagonal of a rhombus bisects two angles of the rhombus. So the measure of angle 1 is 78, since this is bisected here. Theorem 6.10 states that the diagonals of a rhombus are perpendicular. So the measure of angle 2 is 90 degrees because it's at the intersection. Perpendicular means it's 90 degrees. Because the four angles formed by the diagonals must all have the measure 90 degrees, angle 3 and angle ABD, must be complementary. Because if we look at that as a triangle, we know all the angles in the center are 90 degrees. So that means there's only 90 degrees left for these other two angles. Okay. So measure of angle 3 equals 90 minus 78, which is 12. So angle 3 is 12 degrees. Finally, because BC equals DC, the isosceles triangle theorem allows you to conclude that the measure of angle 1 is congruent to 4. So the measure of angle 4 is 12. One more example here. Find the length of a diagonal. One diagonal of the rectangle is 8x plus 2. The other is 5x plus 11. Find the length. So theorem 611 says that the diagonals of a rectangle are congruent. We can set these equations equal to each other. So 5x plus 11 equals 8x plus 2. If we subtract 5x from each side, we have 11 equals 3x plus 2. If we subtract 2 from each side, we have 9 equals 3x. And if we divide by 3, x equals 3. So then I can plug in 3 for x. 8 times 3 is 24, plus 2 is 26. 5 times 3 is 15, plus 11 is 26. So each diagonal is 26. Okay, and then I'm just going to have you do this one check for understanding problem on page 108. Find the measure of the number of angles in the rhombus. And remember that the diagonals bisect each other, so that should help you figure some of those out. I will make a video about how to do that. So right now, go ahead and get started on that problem.